What we have is a speed time graph. On the y-axis we have speed, it's given as meters per second, and along the x-axis we've got the time. The area under the graph, right, the bit that I'm shading over here, that gives you the total distance travelled between 0 and 150 seconds. Right, that's actually given to you in the question. If you look at the next paragraph, the journey took 150 seconds. We know that, we can see that from the graph. The train travelled for 1.53 kilometers. And I'm going to change that to meters because you can see on the y-axis it's giving you meters per second. Right, meters per second. We know 1 kilometer is the same as 1,000 meters. Therefore, to find out what 1.53 kilometers is, you have to times by 1,000 to convert that into meters. So if you times that by 1,000, you get 1,530 meters. Right, that's the total distance travelled in 150 seconds. What they want is this value here, v. Or in other words, they want to know the height. They need to know the height of this. So obviously the speed starts at 0 and it increases and it reaches a certain value, the maximum value, and it stays constant, and then it starts decreasing, the speed starts decreasing until it comes to a standstill. Now, as I've said, the area under the graph gives you the total distance travelled, and I'm talking about area. Well, this is a trapezium. The formula for a trapezium, to work out the area of a trapezium, is half a plus bh, where h is the gap between the two parallel sides. This and this are the two parallel sides. The h is actually the gap. So by working out h, I've actually worked out the height. It's what I need. It's the maximum value of the speed. Right, A and B are the two parallel sides. This is your A, you can call that one A, you can call all of this, B. So A is equal to, what's the difference between 95 and 45? It's 50, isn't it? 50 seconds. And what's the gap? Well, you don't need to know the gap. The value of B is 150. From here to here, it's 150. So B is equal to 150 seconds. And the only thing that we don't know is h, but we do know the area under the graph. The area under the graph is given as 1,530 meters. Right. The value of the A is given as I've said, as I've written down here, is 50, and the value of B I've written down as 150. Right. The only thing I don't know is h, and that's what I'm after. So what I can do is just solve this. 150 add 50. 150 add 50 is 200. Half of 200 is 100. Then just divide by 100. Divide by 100 both sides. I'll get 15.3 on the left, and the hundreds cancel. That's h. So the value of h I've just worked out is 15.3. Right, all the way. That's 15.3. This is equal to 15.3 is your answer. 15.3 meters per second.